Alright, there's been some confusion with our homework that was due Monday, so I thought I'd go ahead and make a quick video on how to do a couple of those problems since we didn't get to it in class. So let's take a look at this problem where we're trying to raise a very large number, like 1,812, to a very large power, let's just say 48. If you try and do this in your calculator, you'll notice that you can't get an answer because there's an overflow. Your calculator can only have so many digits that it will display, even as scientific notation, and we've exceeded that number of digits. But there is a way to do this using logs, so let's go ahead and see how we would do that. Alright, I'm going to go ahead and take the log base 10 of this equation on each side. And remember, when we're solving, I'm going to go ahead and put that equal to y. That's a pretty key step that a lot of people have been forgetting lately. So let's go ahead and take the log on each side. So I'm going to take log 1812 to the 48th power equals the log of y. And using my power rule for logs, I know I have to bring this 48 over out to the front here. So I'm going to rewrite this as 48 log of 1812 equals the log of y. Well, 48 log of 1812 is simply a number, so let's go ahead and put that in our calculator and see what it is. Go ahead and do that now. See if you get the same thing as I do. Alright, did you get 156.39? And we'll make that, just to make it simpler, we'll make it 156.4 equals the log of y. So that wasn't too bad. But I don't really want to know what the log of y is. I want to know what y is. So I'm going to go ahead and change this back into exponential form. Well, it's base 10, right? There's a 10 here, even though we don't write it. So I'm going to put that this is 10 to the 156.4 power equals y. Well, look at that. I figured out what the answer is for y in scientific notation. But what's weird is that I'm not really used to seeing 10 to a power where the power has a decimal in it. That's where it gets a little bit confusing. So let's break that down a little bit further because that's not normally how I see things, alright? So we're simply taking the log base 10 right here of each side, right? We're evaluating that log. And we're coming up right here with our exponent and raising that to a power of 10. Okay, so we had 10 raised to the 156.4 power. But we can change that up a little bit, and we can write that that is really 10 to the 156th power times 10 to the 0.4 power. It's starting to look a little bit better, but let's see what 10 to the 0.4 power is. Check that in your calculator now. When I put that in my calculator, I don't round to the 0.4. I simply raise that to the 10 to the whatever 156.4 with that decimal minus 156 is, and I got 2.464. So 2.464 times this, which was left, 10 to the 156th power. There we go. That's our answer. So just a quick summary for you then. What we're seeing here is we're simply taking the log base 10. So if we kind of go back a little bit, then we're taking that, we're kind of splitting that up into two parts. A part with a whole number exponent and a part with a decimal exponent. We're evaluating this decimal exponent, and that becomes this number right here. So that's all we're trying to do, okay? Good luck.